Take a look today. I just want to extend what we did on Friday just a little bit. Shouldn't take terribly long. Want to go through a few examples. Should have a little time to work. I will give you a work day tomorrow. Wednesday we'll add something new. Probably guessing we'll do like a work day Thursday. I'm sorry. Oh, there you go. Yeah. Birthday, work day. There you go. And then Friday will be the last thing that we'll cover, last topic. Okay, and then so I'll put up on Friday, I'll put up the assignment, I'll put up the review materials, and we'll do the test probably like a week from this Wednesday kind of a thing. And that's our last test. Okay, good deal. All right, so a couple problems here to look at. Stuff, again, extension of what we talked about Friday. What's your thinking on a problem like this? How would you probably approach this? Say it again. Okay, so you're proposing turning this into a radical? Okay, we might eventually do that, right? We might eventually turn that into a radical, but if I do right now, what's going to happen here? Look, I've really got coefficients times powers of x, right? So what would you do in a situation like, what if this didn't look so funky? What if this looked more just like, oh, what if I asked you to do 2x times 3x squared? What's the answer? 6x squared? 6x cubed, right? Because wouldn't you, in that situation, wouldn't you just choose the order in which you multiplied these four things together? We'll multiply the coefficients first. 2 times 3 is 6. And then we'll multiply the variables. X to the 1 times x squared is x cubed, right? So we do the same strategy when we've got rational exponents. Okay, so we're just going to get our coefficients. 5 times 7 is 35. And then we're going to have the product of x to the 1/3 times x to the 1/5. Okay, now if I turn those into radicals now, I'm going to get a cube root times a fifth root. What are you going to do with that? Right? Those aren't, what would I do? They're not like roots. I mean, I'd kind of be stuck, wouldn't I? As we talked about on Friday, the strategy a lot of times for us is to convert radicals into fractional exponents so I can combine them using my properties of exponents. Well, that's already been done here, right? These didn't even start off as radicals. They're already fractional exponents. How can I deal with this part here? What did we do down here? How did we get x to the 1 times x to the 2 equals x to the 3? Yeah, okay, because when we multiply like bases, we add exponents, don't we? Right? So then this part right here is really just going to become x to the 1/3 plus 1/5, right? So the only really challenging part of this is we've just got to add up those fractions, but we can do that, right? We can add fractions up. So let's go through that process then. How am I going to add 1/3 plus 1/5? Let's just deal with just the part up here, just the fraction part. 1/3 plus 1/5. What do we have to get when we add fractions? Yeah, we got a common denominator, don't we? Right? Remember, when we add or subtract fractions, we always need to get a common denominator. Adding and subtracting fractions is tougher than multiplying fractions because you multiply just straight across, don't you? Okay, so what is the LCD going to be here? What do you think? It's 15, exactly. Perfect, because 15 is the smallest number that 3 and 5 both divide into. Good job. Okay, so Abby, then what would I have to multiply? Now, the 1/3, I'm just going to multiply the top and the bottom by something to get my common denominator. What would that be? 5. You got it, 5. So we're going to multiply top and bottom by 5 there. What would I multiply the 1/5 by top and bottom? 3. And look what happens then. We get our first fraction becomes 5/15. Second fraction, then we got a plus sign, right? So we plus second fraction becomes 3/15. So what's the answer? What's 5/15 plus 3/15? 8/15. Exactly, because once we get a common denominator, remember what we do, then we push the fractions together with a common denominator, and we just get 5 plus 3 over my common denominator of 15 equals 8/15, right? So how about that then? We just get x to the 1/3 plus the power 1/3 plus 1/5 is just the same thing as x to the 8/15, which means that our final answer is just 35. Well, it's not our final answer. It's very close. 35 times x to the 8/15. So the last step, it tells us to write your answer using a radical. So now I got to just, last part of this, I just got to deal with writing this as a radical, okay? So what's that going to look like? Where does the 35 go? If I write a radical, remember, radicals always consist of two parts, the outside part and the inside part. Say it again. Inside or outside? Does it? Is the 35 being taken to, like, is it being taken to a fractional exponent? The x does, right? The 35 staying outside, isn't it? Right? Like if I had rewritten this first factor out here, 5 times x to the 1/3, what would that have looked like? 5 times x to the 1/3 would have just looked like 5 times the cube root of x, wouldn't it? The 5 is outside, right? Same thing here. The 7 is outside, okay? So the 35 stays outside the radical. What about the x to the 8/15? We got to think back to Friday. Okay, so the 15 is going to be the index, isn't it? Right? The denominator becomes the index of the radical. So the 15 goes there. And then what goes inside? X to the 8th. Yeah, right? Remember that? And that just comes from this stuff right here, doesn't it? 8, a to the m over n means that the n is the index of the radical, and the m ends up being the power of a. Okay, give me 1 to 5 on that. Okay, good, good. So there's our final answer. Why don't you guys try one of these and then we'll talk about it. Actually, let's do this one together and then I'm going to give you a different one. Then we'll go up and practice. Okay, what about this? What am I going to do here? I've got a property, right, of exponents that applies. And what's nice about this is when it's written as a fractional exponent, we can use properties of exponents. What's the answer to this? What's this property if I have a product of stuff taken to a power? How can I rewrite that? Okay, good. Yeah, I could write that as a to the m times b to the m. What do we do? Well, when we've got a product, so stuff is being multiplied inside, I can distribute the exponent to each factor in that product, right? So in this case, the 1/3 can go to the 216, and it can go to the x to the 15, right? Okay, so then we get this. This looks like 216 to the 1/3 times x to the 15 to the 1/3. Okay, let's deal with these individually. What about the 216 to the 1/3? What am I going to do with that? Make it a cube root, sure. We could make it a cube root of 216, okay? So this part becomes the cube root. What kind of color code this here? This part's going to become, well, I'll do it this way. Becomes the cube root of 216, which I can simplify, right? And we'll get to that, times, what about this part? X to the 15th to the 1/3. Now, what's my property if I take a power to a power? What did we say we did there? Like a to the m to the n. What did I do there, Arson? What do I do there? You multiply. There you go. I get a to the m times n. So then x to the 15 to the 1/3 just becomes x to what power? Yeah, the 5. Okay, so we just have to deal with that cube root of 216. How do we simplify radicals again? If it's a cube root, there you go. So we're going to factor it. Triples go out. Everything else stays in. Okay. So we would make a factored tree out of 216. Okay. What's something that divides evenly into 216? 9 does. Good, because 2 plus 1 plus 6 adds up to 9, which is divisible by 9. Good job. So we could make that into a 9 times, 9 goes into 21. How many times evenly? 2. With how many left over? 3. Okay, so then we bring the 3 up here. We've taken care of the 2 and the 1. 9 goes into 36. 4 times. Okay. So then let's see. The 9 we could break down into a 3 and a 3. The 24 we could break down into 6 and 4. Okay. Say it again. We could do 3 and 8 also. That, yeah, either way. And then the 6 is going to break down into a 2 and a 3. The 4 breaks down into a 2 and a 2. So now let's do it when we're dealing with these bigger roots. We always want to write this out as a string of products, right? So we get, these are our prime factors, starting with the smallest type of factor, which is a 2. How many of those do I get? 2 times 1, 2, 3. Okay, good. 2 times 2 times 2. And then we get 3s, and I get 3 3s. So then look, I get triple 2s, triple 3s, and nothing else, right? So this works out well, doesn't it? The cube root of 16, this just becomes 2 times 3 with nothing stuck inside. Okay, so then look, I get 2 times 3 times x to the 5th. If I tie all that together, isn't that just 6 x to the 5th? Okay. Anything we can take away from that? I mean, I think we got it covered, right? You're going to split it into, you're going to distribute that exponent because these things are being multiplied. Now, if they were being added or subtracted, could we distribute the exponent? Like if I had something that looked like this, a plus b to the power m, can I distribute the exponent? I can't. You're right. Because what does that mean? It means a plus b times a plus b times a plus b till I have m of those together, right? That's a Pascal's triangle thing, right? That's much harder, okay? So only when they're being multiplied. All right. Why don't you guys, is that a good one to do? I'm gonna let you guys do that one. Yeah, I actually go try that one. Go do that one real quick. Okay, so when we take a power to a power, you've already told me correctly that we multiply exponents, right? So this just becomes y to the 1/6 times 5/3. Multiplying exponents is easy. You just multiply straight across. So I get y to the 5/18, which means if I write that as a radical, which number goes as the index of the radical, the top or bottom of the fraction? The bottom, yeah. So the 18 goes there and the 5 goes there. Good job. Okay, try that one. Okay, so first step, great idea, is we want to convert these into rational exponents, right? So we can use our properties of exponents. Good. So on the top then, this guy is just going to become w to the 4/3 divided by, this guy becomes w to the 4/5. Okay, now we got to think about properties of exponents. What's our property when we divide like bases? What do we do when we divide like bases? Because the bases are the same, aren't they? Look, I've got w's. Ah, there you go. You subtract, don't you? There you go. Okay, we subtract exponents. So keep going.